What is actually happening in your brain when you fall in love? Not the poetry, the real, measurable chemistry. Scientists have been studying love in the lab for decades, and what they have found is extraordinary. Love is not just an emotion. It is a neurochemical event of staggering complexity. Today, we go inside it. The moment you are attracted to someone, your brain lights up like a reward system on fire. Dopamine, the same chemical released by gambling and cocaine, floods your prefrontal cortex. Norepinephrine spikes, serotonin drops. This is why early attraction feels euphoric, obsessive, and slightly irrational. Your body is running on the chemistry of obsession. Is love at first sight real? Within 90 seconds of meeting someone, your brain is already processing facial symmetry, voice pitch, body language, and scent, all below conscious awareness. What we call love at first sight is an intense neurochemical attraction response. The brain narrates as love in retrospect. The feeling is real. The love that follows still has to be built. Attraction is a multi-channel signal processed before you have spoken a word. Facial symmetry signals genetic health. Voice pitch affects perceived attractiveness more than most people realize. Posture signals confidence. And then there is the channel nobody talks about, operating entirely below conscious awareness. Scent. Research into MHC genes, which govern immune function, shows that people consistently rate the scent of individuals with different immune profiles as more attractive. We are essentially smelling genetic complementarity. The implication is profound. Your immune system is participating in your love life. MRI scans of people looking at photos of someone they love show something remarkable. The regions governing critical judgment go quiet. The ancient reward centers, nucleus accumbens, ventral tegmental area, caudate nucleus, blaze with activity. Love literally suppresses your capacity for critical evaluation. Evolution designed this on purpose. If dopamine is the spark, oxytocin is the architecture. Released during touch, eye contact, and intimacy, it creates the feeling of being genuinely safe with someone, and it operates as a feedback loop. The more you bond, the more oxytocin you release, which deepens the bond further. This is why long-term partners feel irreplaceable. Early-stage love activates the same neural pathways as addiction. Brain scans of people newly in love look strikingly similar to cocaine users. Intense reward activation, reduced prefrontal control, compulsive focus. This explains why rejection feels like withdrawal. The early stages of love are genuinely one of the most powerful, altered states the brain can enter. Helen Fisher identified 3 neurochemical systems in love. Lust, driven by testosterone and estrogen. Attraction, driven by dopamine and norepinephrine. And attachment, governed by oxytocin and vasopressin. These systems operate independently. You can have one without the others, which is exactly why relationships are so complicated. Heartbreak is not a metaphor. It is a neurological event. When a relationship ends, the neurochemical supply your brain had adapted to suddenly stops, resembling withdrawal. fMRI studies show that rejection activates the same brain regions as physical pain. One study found acetaminophen reduced emotional pain as effectively as physical pain. Your grief is real on a cellular level. Arthur Aaron found that the key driver of long-term attraction is self-expansion, the degree to which a partner helps you grow. Couples who stay curious and seek novelty together sustain higher dopamine activity years in. The brain is novelty-seeking by design. Love that keeps surprising you keeps the reward system engaged. Genuine intimacy cannot occur without the willingness to be seen fully. When someone knows your uncertainty and responds with care, your brain registers this as profound safety, and oxytocin release is significant. Lasting love is built not in impressive moments, but in honest ones, in the willingness to be known rather than admired. New love and long-term love are chemically different. Early love blazes with dopamine. Long-term love in couples still deeply in love after decades shows activity in regions associated with calm attachment, empathy, and the opioid system. Lasting love is not the absence of passion. It is a warmer, deeper neurochemical state built on thousands of ordinary chosen days. Oxytocin bonding, once established, does not require constant proximity. Voice, video, and shared rituals sustain it. What matters most in long-distance relationships is not geography. It is perceived commitment and a clear timeline toward reunion. Uncertainty about the future is the more damaging variable than distance. Love evolved to solve a specific problem. Human infants require years of care, so parents needed to stay bonded. Oxytocin, vasopressin, and the opiate reward of proximity evolved to make this happen. No other animal layers sexual attraction, intellectual companionship, emotional intimacy, and commitment into a single ideal. Human love is evolutionarily recent and neurologically demanding. Self-compassion activates the brain's caregiving system, including oxytocin directed toward the self. Research by Kristen Neff shows that people with higher self-compassion have lower stress reactivity, greater capacity for intimacy, and more stable relationships. The chemistry you develop toward yourself is the template from which your capacity to love others is built. You cannot fully choose who you fall in love with. The initial attraction is largely unconscious, but you can choose where you place your attention afterward, who you spend time with, what you invest in. Love may begin as chemistry, but it is sustained by choices. Falling in love may be involuntary. Staying in love is a practice. After all the dopamine, oxytocin, and reward circuits, what the research consistently returns to is this: the quality of your close relationships is the single greatest predictor of happiness and health across a lifetime. The Harvard study followed 724 men for 80 years. Close relationships outperformed money, fame, and achievement on every measure. Love is the point. The chemistry is just how it gets into the body. The same oxytocin system that produces romantic love also produces the bond between parents and children, between close friends, within communities. Love is one chemical system, expressing itself across all human connection. This means love is not scarce. The more you practice genuine connection in any form, the more capable your brain becomes of producing it. We are wired for connection at a level deeper than language, deeper than culture, deeper than conscious choice. Understanding the chemistry does not make love less magical. It makes it more extraordinary. Subscribe to Mind Decoded. Every week we break down the psychology of the mind most people never take time to understand. We will see you there.